Hello dear learner, I welcome you in the lecture series of Fundamentals of Data Structure. In today's session, we are going to start with the stat application. We'll see how to convert infix to postfix expression. At the end of this session, I expect my student will be able to understand that different expression notation like infix, prefix, postfix, and they can implement the program for infix expression to the postfix form. These are the few reference books I suggest for your more understanding. Let's start with the arithmetic expression. We know that we can write the arithmetic expression in the form of infix, prefix, and the postfix notation. Means every expression is consist of the operators and the operand. If we take the example of the binary operator, for binary operator we require two operand. Then where we place the operator in these two operands, depending upon that, our expressions is represented into the three ways like infix, postfix, and the prefix. In the infix expression, operator comes between the two operands. Means if I would like to say that 10 plus 20, then we will say that 10 plus 20. So 10 is the operand 1, plus is the operator, and 20 is the operand 2. If we use the postfix expression, this it indicates that the operator comes after that respective operands. Means if I say a plus b, I want to represent in terms of the postfix expression, then we can represent it by a b plus. Means we are saying that this plus operator indicates that we want to do the addition of the content of a and b, but this addition is postponed. Means we are storing the value of a, then we are storing the value of b, and then if we get that the plus, then we can say we would like to add the value of a with b. If we are putting this operand before that operands, if we are putting the operators before that operands, then it is called as the prefix operator. Means before starting with the operand, right? Means we are putting that particular operator. So like this way, our expressions are represented by three ways: infix, postfix, and the prefix expression. While we in the prefix expression, we generally we say a plus b, but a plus b it indicates that we would like to perform that a and b will be added over there in specifically infix expression. But in the prefix case, we would like to say that add ab. This indicates that plus ab. Similarly, if we want to say that multiply AB, it will be written as star AB. Means multiplication will be done on value of A and B. Then the question is that if we know and we are familiar with the infix expression, then how do we convert the given expression into the postfix form and the prefix form? So there are two ways. One way is the manual transformation, and another is that we can perform or write a program for that conversion of infix to the postfix form. Let's see the first manual transformation. Here, what we have to do, we have to take the infix expression, then we need to convert that expression into a fully parenthesized expression. Means we would like to use the explicit parenthesis depending upon that the arithmetic operator precedence. Then we need to convert that fully parenthesized expression into the postfix notation by simply starting with that innermost expression. Into that, we would like to take the operator, and that operator will be shifted to the closing parenthesis. Means that operator will be shifted to the right hand side of that particular operands. And at the end, we would like to remove all the parentheses. Right? Means what we are doing? We are taking that infix expression. That expression will be converted into the fully parenthesized expression. Means we are giving some parenthesis. While we are giving the parenthesis, we need to take care about the arithmetic operator precedence. Then we would like to convert into that postfix form. Then that respective operator will be shifted to the right hand side of that particular operand, or we can say that closing parenthesis of that respective expression. At the end, we would have to remove all the parentheses. Let's see with one example. Assume that this is our infix expression. that it indicates A plus B multiplied by C. Then we have to convert this expression into a arithmetic fully parenthesized expression. Into that fully parenthesized expression means we would like to say that by the operator precedence that multiplication will be evaluated first, then we would like to evaluate that add. Means depending upon that arithmetic operator precedence, we have to give that parenthesis to them. Then what is its next step? We have to shift the respective operands to the right hand side, or we can say that closing to our closing parenthesis. So we can say that multiplication operator will be shifted here and this plus operator will be shifted over here, right? So we are getting that the expression in this form. At the end, we have to remove all these parentheses. Then we get that A, B star and plus. This is the output we are expecting. That means this is a postfix expression of this given infix expression. Take another example. So I request kindly pause the video and try to solve this example. We'd have to first convert fully parenthesized expression, then move this operator onto the respective right hand side. Then we need to remove all the parentheses. Then finally we'll get the postfix form. Dear student, I expect you have solved that example. Let's see how we can do. So here what we are getting that the closing multiplication operator is having that higher precedence. Then again we are saying that E multiplied by F will be evaluated first. And then by the associativity that we are saying that these operators will be evaluated first, right? Then we are saying that plus and minus operator will be executed. So this is the resultant parenthesis we are getting. Then what we need to do? We need to shift this plus to this closing parenthesis. Then we need to shift this multiplication to this closing parenthesis. Likewise, we need to shift all these operator with their respective closing parenthesis. And at the end, we people are getting this is the resultant output. And finally, remove all the parentheses. So this is our the resultant postfix expression. So in manual conversion, what we are doing? We are moving each operator to the right of its operand and then we are removing all the parentheses and finally we'll get the our resultant postfix notation for this given expression. Here we are not changing the operand orders, right? We are simply saying that the operators are evaluated into their respective order of evaluation. If we see in this example that the bracket will be solved first, means A plus B will be evaluated first. So in the same fashion, A plus B will be evaluated. Then we are saying that the result of E and B, okay, A plus B will be multiplied with the C. So like this fashion, its result and C are going to be get multiplied over here, right? So we are saying that operand order doesn't change, but operators are evaluated in the given order. If we take this another example, then we need to make this expression as a fully parenthesized expression. Then we need to respectively shift all the operands to their right hand side. And finally, we'll get this is the resultant postfix expression for our given infix notation. This is all about the manual conversion. Then how we can do with help of programming. So for this reason that let's see that what is our algorithm. That first algorithm we are saying that a input will be taken is a fully parenthesized expression and then we are going to convert into that postfix form. Means our input is a fully parenthesized infix expression. With help of stack, we are converting such an expression into the postfix form. So for the simplicity is, we are saying that output list is our output and definitely we people are using a stack. The use of stack is that where we are going to store all the operators. Then we have to take the input string. That input string will be splitted into the list of token. For example, if I am having the expression is opening parenthesis A plus B and then closing parenthesis. So here what we are getting? We are getting the first token is the opening parenthesis. Another token is E. Next token is plus. Next one is B. And next one is a closing bracket, closing parenthesis. Means we are getting the tokens are opening parenthesis, closing parenthesis, operator and two operands over here, right? Then we have to read this input string from left to right. Then what type of token we are getting? Accordingly, we people are some performing some operations. Let's see what are that operation. We have to read the token from left to right side. If it is operand, means if either E or B, then E and B will be directly copied into our output list. If it is the operator, then we need to take that particular operator and push it onto the stack. If it is a opening parenthesis, then again that parenthesis we need to push onto that stack. But when we are getting the closing parenthesis, then we need to pop the items one by one until we don't get the closing parenthesis. Let's see the one example. Assume that we are having this expression. So here, if you observe that the first input is opening parenthesis, then what we have to do? As it is the opening parenthesis, we need to push this opening parenthesis onto the stack. So our content of stack becomes this one, right? Then again we are getting that the second opening parenthesis. Again it is the opening parenthesis, we need to push it onto the stack. Again, the third expression, third token is that opening parenthesis. We need to push it onto that stack. Now, we are getting that our expression is containing the token of our expression is A. A is the operand. Then what we have to do? We have to append it to that output screen, output list. Now here we are not having anything. So we are saying it is empty. Now A has been copied into our output list. So this is our stack as it is, and this is our modified expression. So next input is plus. Plus is the operator. If it is operator, then we need to push it onto that stack. Okay. Again, if it is an operand, then we need to write copy into that output list as it is. Fine. So like this way, we are our A and B has been copied over here. Now, if you observe that we are getting this a closing parenthesis, then what do we need to do? We need to pop from the stack until we won't get that closing opening parenthesis over here. Means we are popping plus copy into that output list, and when we are getting that opening parenthesis for the respective of this closing parenthesis, then we need to stop popping from that stack. So here we are getting this pair. So that's why this plus will be appended onto that output screen, right? After finishing it, again we are getting multiplication. It is operator, so push it onto that stack. Next one is opening parenthesis. Again we need to push it onto that stack. So our output is as it is. Next one is C, operator. That's why copy onto that output list. Then minus operator. So push onto that stack. Similarly, we are having that all these operations, and we will take the respective operations or respective steps depending upon that what is the token. Now assume that we are having the list is that input is containing the closing parenthesis and our output list is AB plus CE. Then what we have to do for this closing parenthesis? We need to pop from the stack and copy onto that output screen. Similarly, this is the closing parenthesis. Then again multiplication we need to copy onto that output list. Then division is the operator. That's why we need to push it onto that stack. Then similarly opening parenthesis F plus operator push G we need to copy into output screen. Then closing parenthesis, then this plus will be popped and copy into output string, right? So our plus will be here. Then again we need to go for that next. So again we are getting what? That closing parenthesis. That's why pop this operator and copy here. Then input is empty, stack is also empty. Then we can say our resultant expression is stored into this output list, and this is our the postfix expression of given infix expression. The problem is here that we need to tackle too many parentheses over here, and also we have to apply the parentheses depending upon that precedence rules. So for this reason that we people are going to modify our algorithm of conversion of infix to postfix. Means if the infix expression even though is not fully parenthesized, still we can able to perform that infix to postfix conversion. As like we are holding a stack for operators and our output list which is containing the postfix conversion. Then again we need to read the input string, and that input is divided into that number of tokens. Similarly, if we have to start with reading the list or reading the tokens from left to right, if it is operand, we need to copy onto the output list. If it is opening parenthesis, push onto the stack. If it is closing parenthesis, pop from the stack and append to the output list until we don't get the respective opening parenthesis. But if it is operator, then we need to check the top of the stack means assume that our stack is containing some operators. Okay, let it is the multiplication operator and my input is the division operator. Then we are comparing that the multiplication and this is our a division operator. Then who is having the higher precedence? If our stack top is having the higher precedence, then we need to pop that operator. Otherwise, we need to push this operator onto that stack. Means here, if our peak is having the higher or equal to, means the same precedence, then we need to pop this multiplication operator and copy onto our output list. And then later, this operator, division operator, will be pushed onto that stack. So we need to check the precedence of our stack top and we need to compare with our input operator. If precedence of this stack top is greater than or equal to this input, then we need to perform that pop from the stack and then append it to that output list. If it is not the case, then we need to push it onto that stack. Once our all the input has been aimed, then and if there are something is left, means some operators are left in our stack, then we need to perform pop all that operator from that stack and append it to the output list. So this is our the modified algorithm which is not applied, or we can say if our input is not the fully parenthesized expression, still we can able to solve that example. Let's see this example here. So what we are saying that if a initially this is our input string, stack is empty, nothing is there on our output expression, so this is our the initial condition. Then a is the operand, right? That's why we have to copy onto that output list. B is the operator, therefore perform push. That's why it has been pushed onto the stack. Again, B is the operand. That's why we need to copy. It is or we can say concatenate to this A. Then again we are getting this multiplication, right? And then our stack top is plus. Then we need to check their precedence. So what we get? We get that the stack top is containing the plus operator and token is containing this multiplication operator. Means obviously our stack top is having less precedence. Therefore, we need to push this multiplication operator onto that stack. Next, we are having that C is the operand, copy onto that output list. Then again, we are getting this subtraction. Then we have to compare with the priority, what is the top of the stack. The top of the stack is containing this multiplication, means what we are saying, that multiplication is having the higher precedence than that of this minus. That's why we have to pop it from the stack and copy onto this output list. So our stack is empty now, right? Then again we are getting that minus and assume that, okay, now here our stack is also containing that plus. then what we are getting that if our stack top is greater than or is equal to of our input token, so what we are getting, plus is having the same precedence with our minus. So in that case also we are popping this minus and append it to this output list. So here now we are getting the stack is empty and our input is minus. That's why this input is again shifted onto that our stack top. Now D is here, so D has been copied onto this output string. Now this division operator is here, and then our stack top is containing this minus subtraction operator. Then what we are getting, this stack top is having the less precedence. That's why this division operator will be pushed onto that stack. Then E is the we are getting, right? Then that's why E has been copied onto this output stack, that E as an operand. Now our input is empty, but stack is containing the two operands, two operators. That's why pop from this stack and append it to this output list. Again pop from this stack, append it to this output list until our stack doesn't get empty. And when our stack is empty and our input is also empty, then we can say this is our the final conversion, or we can say the result of our postfix expression. Here it should be the postfix expression, not prefix expression. Okay. So what is it conversion? Let's revise the algorithm. We have to create the stack. Input is we are taking the infix expression and the post expression is our output. We have to create the stack, set a token, or we can say set a counter which will keep the trace of that token of our input string until our all the tokens will not be get covered, means, or we can say analyzed. Then we have to perform all these operations. Okay, so we need to take that particular token, then check whether that token is opening parenthesis, then perform push. If it is a closing parenthesis, then pop from the stack, concatenate that popped element to the output expression and again perform that pop. If it is the token is the operator, then we need to perform that, yes, operator precedence. Then we need to check that whether the stack top is having the higher precedence. So we are considering that stack top, means that stack top, whatever the operator is stored, which is we have stored in this top token. Then we are going to compare that precedence of our this stack top and the precedence of our input token. If that the precedence of the stack top is greater, then we need to perform pop. Otherwise, we need to append onto this, we need to push that particular token onto that stack. And if the token is operand, then we need to copy that token onto this output string. When our input infix expression is empty, then we need to pop all the stack items and attach it to this postfix expression. So we need to apply until our stack doesn't empty, pop from that stack and concatenate to this postfix expression. So this is the conversion of infix to postfix expression. So dear student, I expect you kindly pause the video and try to solve this example with this algorithm. So here that evaluation have been given. Kindly check out that your answer with this solution. So if it is the C, means if you are saying that the C is the operand, that's why it is being copied onto this postfix expression. Now plus is the operator, right? That's why we need to push it onto that stack, right? Similarly, we need to apply our all the rules until we won't get that the input is empty and the stack is empty. Okay, so this is the final conversion, or we can say from the infix to the postfix expression. So dear student, so this ends our that conversion of infix to postfix expression. In the next session, we will see how to evaluate the prefix expression and the postfix expression. Thank you. Happy learning.